Hey, today I'm going to be doing homework for question number 1. So you stand on a bathroom scale in a stationary elevator and it reads 712 newtons or 160 pounds. The elevator then goes up. The motion of the elevator goes through 3 phases. In phase 1, the elevator speeds up at a rate of 2 meters per second squared. Phase 2, the elevator continues to move up at a constant speed of 6 meters per second. Phase 3, as the elevator approaches its destination, the elevator slows down at a rate of 2 meters per second squared. So for the first part, part A, we're going to have to draw a motion diagram for the motion of the person in the elevator. Make sure you label delta V and the acceleration at different points of the diagram. So here we have a motion diagram for the 3 different phases. So the elevator is moving upwards. So we start at a lower spot and then we're going to end up at a higher spot. And at stop, V0, there should be no arrows pointing anywhere because it's not moving yet. The elevator has not started and it has not moved. And once the elevator begins to start moving upwards, in phase 1, it's accelerating. So V0, it's not moving, and acceleration is at 0. And V1, there's a small arrow, and the acceleration goes up 2 meters per second squared. And now it's moving up. And the next part, you see there's a longer arrow because acceleration is still increasing. So 2 plus 2 is 4, so it should be double the length. And finally, to complete phase 1, you have V3. Acceleration is still at 2 meters per second squared. So it's the longest out of these 3 arrows because it's 2 plus 2 plus 2, and it reaches velocity of 6. Which brings us to phase 2. Where the elevator moves at a constant speed of 6 meters per second. So this arrow is going to be the same as this arrow because it's moving constant 6 meters per second, and all these, the acceleration kept adding onto itself and slowly increased to become 6. So once the velocity reach 6, it becomes constant. It's not going any faster, it's not going any slower. So acceleration here would be at 0. And when it is about to reach its destination, the elevator is going to slow down by 2 meters per second squared until it reaches its destination. So here we have the opposite of what we have here. We have long arrows becoming short arrows, with acceleration decreasing by 2 meters per second squared until it reaches 0. And now for part B, we have to draw some force diagrams for each of the phases. So in phase 1, we have the elevator accelerating, so there is a lot longer arrow on top indicating that it is moving upwards. And not just moving upwards, but it's also accelerating. Phase 2, the elevator is still going up, but because it's already going up, the velocity, the motion of it is going up. It is going up at a constant rate. And so the arrows are the same. And you may be thinking, or maybe you want to ask, why are they the same if it's still going up? Because you don't want any arrow to be longer than the other because that affects acceleration. And acceleration at this point is 0 because it's going up constant. And because it's already going up constant, we don't have to add any more force to make it continue to go up. And finally, for phase 3, when the elevator is decelerating, there will need to be more downward force because the elevator is going up, and force needs to be applied to the opposite direction for it to start slowing down. And finally, for part C, what does the scale read during each of these 3 phases in the motion of the elevator. So this one was, I thought it was going to be pretty easy, but I'll just do my best to explain what I got. So we're using the equation A is equal to Fm because we are given acceleration, we're given the F, and we're trying to find mass. And so we can use some algebra and rearrange this equation to find the mass. And by rearranging this, we're going to multiply m on this side and on this side, and we get ma is equal to F, but we want m by itself, so we're going to have to divide a to get it on this side. So m is equal to Fa. Phase 1 has 3 different calculations because it's increasing from 0 to 2 to 4 to 6, so you're going to have to calculate all those different ones. And we're given F is equal to 712 newtons, and A is 0, 2, 4, 6. So by having this and plugging all of these into the formula, we can compute that at A is equal to 2, when acceleration is at 2 meters per second squared, we're going to put it on top or on the bottom, and we have 712 newtons over the acceleration. We get 356 newtons. For 4 meters per second, we are given 178 newtons. For 6 meters per second, we're given 118 newtons. And so at 2, convert that, weight is 80 pounds. At 4, it'll be 39 pounds, and at 6, it'll be 26 pounds.